Right. Good morning, everyone. We've got a bit of an interesting topic here, so I was always interested to see how many people were going to come along and know what Neo4j was. I was talking to one guy who said he's used Neo4j. How many people have used it already? 1, 2, okay, 3. Okay, a couple of people. And the rest of you, how many people know what a graph database is? Okay, a couple of people. Not so sure. All right, so we'll go through a little bit of terminology to start with. So my name's Taith Modi. I'm a principal consultant with a group called Redify down in Australia. And the reason that I was doing this talk and why I know about Neo4j is I've actually spent the last 12 months with a team using Neo4j on one of our projects as a database. It's our only back-end store. So it's not just like something that we bolted onto the side. We exclusively use it. And we're in production. We have production users, everything like that. So we've gone through that kind of full life cycle. And I actually really quite like it now. Just to complicate things, we run it in Azure as well, which means we have a Java-based graph database running on Azure with a .NET front end. So it made for some interesting debugging problems from time to time, like when you have a performance issue. So start off with what is a GraphDB. It's a NoSQL store, so it's not a relational store or anything like that. And it's basically like a document database where we have nodes which have keys and values, they're property stores, but then we have relationships between them. So if we start off talking about what a graph is, if we imagine that these sort of dots are nodes, and then we have relationships between them, that there is a tree structure. We'll be quite familiar with, it looks very common. As soon as we go and do a link like this, and there's two ways to get to something, that becomes only a graph. It's no longer a tree. So a tree is a graph is not a tree. So this is why it's a graph database. Neo4j is a directed graph database. And what that means is that these links between nodes all have a direction. So the arrow might go that way, and that way. And I missed one. So you always have a direction, whether you like it or not, which is incredibly useful. And then when you're talking about graphs, there's also the term of cyclic or acyclic. Neo4j or graph databases support both. So what cyclic means is we've actually got a kind of a cyclic graph here, which I've drawn out because there's a complete cycle there between all of the nodes. There's a way to get from one to the next and get back to where you started. That doesn't always have to be the case though, because if I go and take that out, that's still perfectly valid, and that's acyclic. So it supports both of them. So that's just a little bit of terminology to start with. Neo4j is just one graph database on the market. It's one of the most mature ones though, and it's the one I'm familiar with, which is why I'm talking about it. There's a good little story about the name, which I only found out about after 9 months of using it, which is why it's called Neo4j. I absolutely hate the J on the end. I'm trying to ignore that. It's kind of like talking about SQL Server for C++, and it scares the .NET programmers away. But the reason it's called Neo is actually a Matrix reference, because Neo is fighting the evil tables all through the Matrix series. So that's why it's Neo4j. We're going to fight the evil tables. And it runs some really big websites, like really, really big ones, big name companies, and there's lots of information about that on their site. More importantly, as far as we care as developers, you can get it for free. So it's the same licensing model as MySQL, where you can get a basic version of it like a community edition, and you can use that for free, and then you only pay for it when you want stuff like clustering and online backups and everything. So getting into why would we use a graph database? Graph databases are really good in highly connected environments where we have lots of things that all relate to each other, and we need to go and walk those relationships, which is a lot of our domain models. Whereas a SQL database is really oriented to dealing with things in aggregate, so where we want to sum things and count things and all those types of processes. So anywhere where you find you're in a SQL database and you're doing lots and lots of joins and you're only getting 1 or 2 rows from each table, and it feels really hard and annoying and your queries are ugly and you have to do all these indexes and everything, that's where you want to be using a GraphDB. That makes that really, really easy. What's nice about that then is it's also very easy to model. So I started a new project a couple of weeks ago, and just getting my head around it, I was talking to the product owner, and I kind of drew out this diagram of going, okay, we've got people and companies have assets, and described things like, okay, companies own an asset, and people can recommend companies, and people want jobs and things like that. So I just scribbled this out on my tablet, and then emailed it to the product owner and said, is this the right model? Have I got it right as a high-level concept? And this is a totally business guy. He really doesn't know how to use a computer very well. And what he sent me back was a PowerPoint file, because that's what business people draw in, right? Everybody draws in PowerPoint. It's where your mock-ups come from. And he went and redrew it like this. And that diagram made perfect sense to him, because he just went, well, we have companies, and then he implicitly went and did all these different colored arrows, and the arrows had directions, and he described the names of them. They're the relationship types. So he's just a business guy who just went and drew it out. So anybody can actually go and model a graph DB, which is really, really nice. So let's get into actually having a look at, we'll run up Neo4j. I'm going to launch Neo4j. We're going to walk through a bit of how we structure data in it and some querying of it. And then I'm going to step back into the .NET world, because this was called Neo4j in .NET, and talk about how we query it from .NET, and then also on the 2 projects I've been using it on, how we deploy it into Azure and also into an on-premises environment. As I go, if you've got any questions, just throw a hand up. As most of the speakers have probably said, though, we've got warned, it's Norway, nobody asks questions. In America, everybody asks questions, and it's because they want to give their opinion rather than actually asking a question. So they talk for a while and pretend it's a question. So Neo4j is Java-based. So if I jump into, I have a temp folder, NDC. I've just downloaded the zip file off their website, and then I've unzipped it. And there we go. So in here, there's a bin folder, and there's just neo4j.bat. And all I do is double-click that. There's no install process. This is just going and running it up on my machine. It's going to bind to a port. I've got a Java window in front there. There we go. So the Java window is now running. And if I go over to my browser, I'm just going to go to localhost 7474, and Neo4j is up and running on my machine. This is the admin console. It's kind of the equivalent of SQL Management Studio or something like that. And we can see that we currently have one node, no properties, no relationships. So let's go and get some data in here, and we can start playing with that. If I minimize my awesome slides. Sorry. Just going to grab a bit of data I built earlier to save us some time. So there's 2 different query languages for Neo4j. One's called Gremlin and one's called Cypher. And what we're going to look at today is one called Cypher. And I just pasted in a Cypher statement there, and we'll go back and have a look at that in a minute. So if I start off in the data browser, we've got this kind of initial node 0, which is what we call our reference node. And I'm going to flip over here into a different visualization mode. So off node 0, what I've created here is this data. I can go and bring these nodes in. And I like to think of node 0 as kind of the system, or whatever it is, the project or the site we're building or something like that. And I describe the relationships off that in that type of terminology. So node 0 has a user, Tatham, has a user, Pat, has a user, Tom. And then off these, we then have other relationships like Tom likes rowing. Tatham, Tom, and Chrissy all like sailing. So very easy relationships, and you can just kind of read through it. The system has a user, Tatham, who likes sailing, and somebody else also likes sailing. And then we can go and query off that very easily. So what I'm going to do, there we go. Unfortunately, this console doesn't work very well with increasing font sizes. Every query we run, we have to start from somewhere in the graph, because there's no like named tables or anything. There's no fixed schema. We just make it all up. We've got to tell it where to start from somewhere. So our query always starts with a start clause, and we'll go and, in this case, say I want to start from node 0, and let's call that root. And then from there, what I want to do is I want to go and match, and I'm going to say from root, there's a relationship that goes out of type has user, and that goes to a person. Return the person. So it's glorified ASCII art. I get paid to write ASCII art all day. It's awesome. Angle brackets and little dashes. So we can see there that there are 4 users in the system. Simple enough. And node 1 there is me. So let's go and run a query against that. So I can say start, me, is node 1. I want to go and match stuff that I like to an activity. Return the activities. There we go. I like sailing and mountain biking. So you can see the kind of directed relationships there of where I've got a dash and then I've got like the arrow off the end. So this here is describing the relationship. Oops, that block there. And then I can just kind of name nodes along the way. What I can also do with this then is, oops, if I say start me is node 1, I want to match things that I like to an activity. And then I want to get coming back into the activity, so you see the arrows going two different ways here, other people who like that activity as well. Return that. So there are other people who like the same activities that I do. Now, can you imagine doing this in SQL? So at this point you have an activities table, you'd have a person table, you'd have a person activities table, and you would have done some god-awful number of inner joins already. But then what I'm looking for here is other people who I don't know who are interested in the same things as me. So I can go, me is node 1. I want to match, oops, me likes activity. And then I want to say where there's not a relationship of me, friend, to that other person, so people I'm not friends with. And in that little clause there, you'll notice I haven't put any angle brackets in. So even though every relationship always has a direction, I can query across that relationship in either direction. So I'm saying I don't care who's originally friends with who. It's kind of a bidirectional thing. It's not really that relevant. We'll just ignore that in the querying. And then I can go and return the person. Now here I've got Chrissy twice. So how's that worked? As it's going out and querying across the graph, it's gone and walked out from me to two different activities, sailing and mountain biking, and then walked out and found her node twice. So it's returned it twice. This is a really weird way to step up in lines. So obviously I can, as you expect, I can just say, give me the distinct nodes. So quite a simple query structure. Is everyone happy with that? Questions about that? Nope. Cool. What this also lets us do is I can actually go and run some kind of more projections as well. So where I have a more complex domain structure. So I can say start with me, match the other people who like the same thing, where I'm not friends with them, and then instead of just returning the person, I want to return the person's name and like a column. So we're going to create a table here out of a graph database or a projection with a count of how many activities there are, and I want to order that by the count of activities. So how many activities do I have in common? Descending. So there I can see there's two different things that this person Chrissy likes that I like as well, and I'm not friends with her. There's this other guy Pat who I'm not friends with, and there's one thing that he likes. I should say, in case my friends actually watch this video, I am friends with both of those people. It just needs to be in the data set that they're not. I get some nasty email from them. You said I wasn't friends with you. All right, so Cypher, here we're using it as a query language. Cypher is also mutable. So in the same way that in SQL, you can do mutations, you can create, update, and delete, you can do that now in Cypher as well. What I will do as well, though, is very briefly talk about Gremlin, which is another query language. And the way Gremlin works is it's very kind of imperative as opposed to Cypher, which we've been using, which is very declarative. So if we look at our kind of model here, what we were doing in Cypher was we were describing a part of the graph, saying something that looks like this, then give us these relevant parts of it. Whereas what we do with Gremlin is we very explicitly say, okay, start at this node, then follow out this relationship, and then when you're here, go out this one, and then get this one. And it's really nicely named. They've got a nice little logo of a character who's a little gremlin. And you can imagine him kind of running around the graph and getting different parts of it. And it's a fluent interface, so the way it works, get the magnifier out of the road, I can say, go and get me V0. Now, why is it V? The wonderful thing about the graph world is that it's quite academic. It depends who you stumble across. So in some places we call them nodes and relationships. In the academic world, they call them vertexes and edges. Nodes are vertexes, relationships are edges, same thing. So here I've got vertex 0, and then what I can do is I can look for all the outbound edges, so we can see those. I can see the inbound vertices for them. I can look at the outbound edges of where they go and like and they're friends with things. And then I can filter that to where it.label equals friend. Dot filter. So that gives me all the friend relationships. And then I can get the incoming vertices. So we've got them. And then I can map out the properties off the end, .map. And I can see them coming out there. So it's a very kind of imperative step-by-step language, which gives you a lot of power. But generally the world's moving towards Cypher. All right, so we're in a .NET world. We don't want to sit here in the equivalent of Management Studio all day writing our application. So what I'm going to do is just go and create a brand new project. So Neo4j has a very nice REST API, which gives you access to go and retrieve individual nodes, put and post them and all that sort of stuff, but also go and send queries to it and saying, here's my Cypher query, please run this for me. And what we've done over the last 12 months of working on this production project is actually built out what we think is a really nice client library for going and querying that. And of course, in the .NET world, because we released something, it's on NuGet. File contains corrupted data. Awesome. All right, I tried to just pull that from my local NuGet store, but we'll download that from the internet instead. So this is an open source project. We work on it quite actively though, because we have kind of 6, 7, 8 developers in our team. And every time we need a feature, we add it to this. So we've got something like almost 900 commits now and 500 tests and all sorts of stuff. And every single time we add a feature, as long as our tests pass, our CI build automatically publishes it to NuGet. So if you use this library at all, sometimes you'll be out of date within an hour, because we'll publish 5 or 6 times a day. Which is fun for bug reports. People say, it's broken. It's like, which version? Oh, no, you're 2 hours behind. All right, so what I need to do here is I'm just going to spin up a new graph client. Graph, not giraffe. And we'll point that at our local data store. That's the REST endpoint. And then one of the things we do need to do is explicitly go and connect the client, because there's a lot of metadata that we don't get about how to talk to Neo4j until we hit the root endpoint. And that allows us to see what version of Neo4j it is, turn features on and off, that sort of stuff. Now, when I talk about the root node, which is that kind of node 0, we always need somewhere to start from. One of the things about node IDs in Neo4j, though, is that they can change, and we never want to persist them anywhere at all. Because from a data storage sense, the way they work is, say you've got node 6, when it wants to go and find the header for that node, it starts in a particular file and it goes node number 6 times 6 bytes in and goes, and that's where it expects it to be. So if you optimize your data store, things can move. So there's a special one here, special property we've got, .root node, that always tells you where it is. But what I want to do is start a Cypher query. So I'm just going to go client.cypher and then say I want to start that query, and the identity is root, and that's the client.root node. And then I can actually have, in Cypher, I can have multiple start points as well. So I can say that node and that node, I want to find stuff that's in the middle of the 2 of them or stuff. Then what we've done here is, this is going to be impossible to magnify into, I think. If I do this, there we go. The start method returns an iCypher fluent query started. So every time you call one of our methods, we go and give you a different interface back that represents what's valid syntactically at that point in the query. So here you get a match clause. And then I can go and do my match and say, okay, so what I'm going to look for here is actually find my own user. So I want to say I'm doing the has user to a user. But now I want to go and filter this because I'm looking for a particular user. I want to find my user, me. So I can put a where clause in here, but we don't want to just have magic strings in our .NET, otherwise there's no point in us having this nice client library. So what I'm going to do first of all is actually go and create the POCOs and say, okay, well whenever we've got a user node, they have a name, which is just a public get set string. And whenever we have an activity, it happens to, for now, look the same. And then what I can do is say where the entity or the identity user here of type user.name equals Tatham. And then say I want to return that as a node of user. Whoops, and I need to return the identity user. So I'm going to put this as Tatham query equals that. And I'm going to say Tatham query dot results dot single, because I'm only expecting to find one node from that. And let's go and just use the F5 key, which I'm normally not a fan of at all. There we go. So off the client, we've gone and done stuff like, we've connected up to the data store. We've gone and pulled back the root API response, so we know where all of the various endpoints are that we need to talk to. But then in this query here, bit hard to, okay. Visual Studio font size would be great if they applied to tooltips. And you can see there we've gone and built out the Cypher query for that. So we've actually taken the C# Lambda and turned that into a Cypher predicate and formatted that out. And then when I go and invoke the results property, it goes and retrieves that node for us. So if we go and jump into our immediate window, I've now got Tatham is a node of user. And I can go .reference.id, tells me the node ID. And if I go .data, I get the POCO there that we've deserialized into. So I get all that nice, just standard property support, not dealing with dictionaries or anything ugly like that. And then from here, I can always start a Cypher query. Like once you've got a node, you then sort of just keep querying off that and walking around the graph. So then what I can go and do is I can do the similar people query. So people who are interested in similar things. So I can say, okay, I want to start a Cypher query off that node, and we'll just call that me. And then I can do the match of me, likes, and activity. And then somebody else who likes the same thing, and you assume they're a person. Whoops. Now, for the where here, I can't easily supply a predicate for the whole not relationship thing, so I can just pass that in as a string. Basically, we support string entry for everything, and we just plumb that into the query, and then where possible, we try and create a nicer .NET wrapper for it. And then say return all of the distinct people. And then I can go person.reference.id and person.data.name. So there in our console, we've gone and retrieved those two nodes, references to them, data, everything. So you see it's actually quite a nice query experience, I think. Biased, slightly biased. All right. And then at some point, though, we have to be able to modify data in our database. One of the things that's the way the REST API works is that you have to retrieve an entire node and then give the entire node back. You can't just update individual properties. With mutable Cypher, you can do that. We haven't quite got all our support in there for that yet. But what I could do is I could go and say, okay, on a person, we now have a property of their age. And then what I could do up here is once we've retrieved Tatham, I can say client.update. We give it the reference to that node, And then what it does is gives us a callback. So it'll go and retrieve that node and then say, okay, here's the node, now update what you want. So I can go and put something in there to go and update that node. If I run that, and we go back to our data browser, we look at node 1, you'll see it's gone and persisted that in there. So one of the things about Neo4j is that it has very simple node models. They're just a property and a value, and then you store primitives in them, which initially feels a little bit restrictive, but as you go and build out a graph, a lot of the power in it is actually keeping very small, simple nodes and then walking the relationships between them. So you actually kind of take a big complex idea like a customer, and then you'll and break that up a bit. So you'll have a customer, and then you'll link off to address nodes and things like that, which means that then querying it is incredibly efficient because you walk from one node to the next, which is it's very optimized to do, and you only walk the paths that you actually need to go down and retrieve the properties you actually need. So you spend a lot less time going and managing things like clustered indexes on join columns and stuff like that, which is kind of nice. So the problem with this, though, is we've started to kind of load all this data into our graph. It's all nice in NoSQL. We can see in our data browser a little bit what's going on, but like I don't have many nodes in here, and it's already starting to get very messy. So how do we actually know what's in the database? We can just go and make stuff up. And this was one of the problems we ran into kind of fairly on in our project. So one of the things we did, if I go into this one, is there's a really nice tool called GraphViz, which has a language called DOT. So it's a graph visualization tool, and DOT is just a language for describing graphs. And so in our source control, just in the root of our project, we started writing up what we called the reference graph. So here we just go and describe like an example case of what we would put in our graph. And then the nice thing about GraphViz is it can actually go and render this for us. So I've got a render documentation.ps1 PowerShell script. And now when I go and open reference graph.svg, I get a nice SVG diagram, oops, as soon as I can zoom, there we go, of an example of kind of what's in my graph. So not actually what's in there, but a source-controlled way of doing that. So whenever we go and update any of our models or POCOs or relationships or anything, we keep this up to date. What we're working on at the moment is actually having a script which can compare this with a real data store. So it's kind of documenting our schema without it being enforced at runtime. That there's a very, very simple project. Code. The project I've been on for the last 12 months, our reference graph looks like this. You'll see it's, oops, the whole touch thing's not working on different res. You'll see it's an incredibly kind of complex model where we've got lots of really, really highly connected data. There's lots of lines going everywhere. And the scenario that we're modeling here is actually a social care system. So you've got, I don't know, the police turn up at a house, mummy's overdosed on drugs, there's 3 kids in the house, the police pick them up, they have to go into emergency care and then into foster care. So there's lots of various relationships we need to trace between people of their incredibly complex family structures in that type of socio-economic space. The whole question of who's your father is very, very complicated. But we also have a very tight relationship between forms and how we manage that and the kind of process around going, okay, they're involved in this foster care program and this is their carer and that carer has done this authorization for this person and all that type of stuff. So it's very much about walking around the nodes relating to an individual and having to query that very efficiently. And we don't do a lot of stuff in aggregate. So this is where a graph database made a lot of sense for us to be able to just go and grow this out very organically. What's also nice about this reference graph here, we actually have one of our CI builds every time we push. If you touch the documentation folder at all, it rebuilds the SVG, drops it on a HTTP location, which is then referenced from our wiki. So just every time we update, push, it's on the wiki. And similar to that kind of diagram I had where the business or the product owner had drawn out all the, what he called, it was actually quite funny. I sent him a file called what connects to what, and he sent back something called what connects _ color spaghetti. But this is a very similar diagram to that, albeit generated from code. And what we've actually found is not so much business users, but some of our BAs who we work with can understand this graph very easily. So they'll go and open the reference graph and go, oh, that's really interesting that we've got that data so close there. Can we go and show that on the screen? Can we query that? Can we do this? And they have a really easy sense of how our data is actually structured, which is nice. So how do we go and deploy this? You saw how easy it was for me to run it up, where I just unzipped something and then just basically double-clicked the batch file and off we went. That's obviously not always going to be the case where you don't just want to run it in process, but was one of the projects I've got at the moment. We have so what I'm going to run here is a PowerShell script setup development environment, which I need to run elevated. Some good little keyboard gymnastics there to launch that process. Control-Shift Windows 2. They're all very close. So what this script is doing is actually installing Neo4j as a service. So if we look at some of what's gone past, you'll see it does Java 1.7 is installed. So we go and check that based on the Java registration. If it's not, this script will actually download that from Oracle, run the MSI silently, and then continue on to the next step. And then what we do is we go and download Neo4j from their distribution site, dist.neo4j.org. So it says Neo4j not installed for this project. Installer is already cached. I've already downloaded on disk. We unzip it. And then what I say is in my web config for this particular project, I say what port I want Neo4j to be run on. Because each of the different sites that we go and run up of like our staging and production and development instances and stuff, the way you segregate the databases is you run multiple instances of Neo4j in its entirety. It's not like SQL with one instance and multiple databases. So I just say in the web config it should be on port 8000. And then what the script does is actually just goes and patches this into the config files, into the Neo4j config files. It says here's your data path, there's the port number you need to be on. The service name should be Neo4j-8000, so it's unique. We go and create the service and we start it up. And then totally in the background, now what I've got, if I go to localhost 8000, is I've got another Neo4j instance running that a website can talk to. So that script there, while it was called setup development environment, is just wrapping what we actually use in our production deployment to go and just install that and run it up on the box. And then at that point, it doesn't matter that any of it's built in Java. You just query it via REST. In the Azure environment, though, this is a little bit more complex. How many people have worked with Azure? Okay, a couple. So Azure is obviously fairly nicely set up in the .NET space. We chose to use it for this project because it gave us a very structured deployment package where as long as we could build that package and we could hand it off to Azure, they would run it up for us. Because the organization we're working with are a very small not-for-profit. They don't have a lot of IT capability. So we needed to be able to go, oh look, the website's down, redeploy it, and just have it run. So the way that actually works is we have, so in Azure you have multiple roles. So we run up a web role, which is where our web application runs, and then we have a worker role. So the worker role is just basically invokes a DLL entry point, and then you can do whatever you want on that box. And then we, in the Azure config, we describe that we need an endpoint to be exposed in here, and we just say that there needs to be an HTTP endpoint there. Then in the Azure world, we've got blob storage, which is kind of like S3 blobs. So each of the web and the worker roles here are actual VMs running Windows installs. So we actually store the JRE and Neo4j itself in blob storage. And then when the worker role runs up, this is very similar to the PowerShell script, we download JRE, install it on the box. We download Neo4j, unzip it on the box. We look for, we ask Azure what the network configuration is of where our endpoint should be. We patch that into the config files because that's the endpoint that they open in the firewall. But then what we need is somewhere to keep our persistent data because the web and the worker roles get completely destroyed and recreated all the time. So we use another feature of Azure which is called Cloud Drive, where in our blob storage we have neo4j.vhd, which is a virtual hard disk file, the same as you'd use with virtual PC or something like that locally. And then we actually mount this from blob storage onto the box as X drive. And then X drive is where we just store all of our persistent data. So we point the Neo4j data store to that. And then that gives us persistent storage. And then we just keep a .NET process around that actually goes and then monitors, is Neo4j still running? So if that monitoring fails at all, then we crash the .NET process, which then allows Azure to detect the worker role has failed, and then it will go and redeploy and rebuild that worker role for us. So that gives us a nice kind of model there. The other thing that we can then do is actually, you can scale out Neo4j across multiple nodes, and they each need to have their own persistent data store, and then they synchronize data between them. So the way that we do that is we just go and have multiple VHDs in here, and we run up one worker role instance for how many nodes we want in the cluster, how many server nodes we want to host our graph nodes, and we point each of them at independent VHDs. And it all works, just. It felt like a lot of sticky tape and string and glue, but it all did actually plug together. And then on the front end, we have an ASP.NET MVC application. Now, to actually get instrumentation all the way through, we also used a product called New Relic, which is a kind of monitoring product. It's like a runtime profiler. And what's really nice about New Relic is they have both .NET CLR and Java JVM support. So that there, actually, we install the New Relic kind of monitoring agent into Neo4j here, and we wrap our MVC application in it as well. And that actually gives us end-to-end traceability of queries. It puts a correlation ID on the underlying requests. So we can see, like, we ran this controller here in .NET, which had this action, which did this HTTP call. It puts a correlation header on it, which then hits the embedded server in Neo4j, which launched this Java class, which then went and ran this query. So we can actually see right down really specifically what queries were impacting our performance, which was kind of cool. See if that comes up. Right, so that's the deployment story. One of the things I was talking about was that the node IDs can change and shift on you, so you can't use them at all. Now, we wanted to have, we needed to be able to expose things in URLs. So the idea of, okay, in a lot of cases, say you're looking at a user profile, you can go and use a username or something like that. That works well enough, but you don't always have a semantic identifier like that to use. So where we had stuff like clients, we'd need a number for them, because A, they don't all have unique names, and also a lot of the types of people we're dealing with, we don't even know their name to start with. It's the kid with the red beanie who's always at the skate park. So we needed a way to be able to generate these unique identifiers. Now, Neo4j doesn't actually have a way of doing these out of the box, and it also doesn't have that kind of sense of schema to understand the different scopes of, well, that's a client and that's a program or something like that. Because we also wanted to be able to do things like we'd have referrals, and then a referral would obviously need a unique number. So one of the other things we built out of this project was a library called Snowmaker, where its whole job is to just generate unique IDs. So it is a distributed, so cloud-capable, guaranteed unique ID generator, which generates longs rather than GUIDs in a mostly sequential and mostly dense fashion. So time-wise, it should be kind of mostly 1, 2, 3, 4, and then sometimes you might skip 6 and you'll get 7, 8. And if you sort it exactly by time across multiple nodes, some of them might be threaded together. So you might get 10, 11, but then by the time you get to like 20 and 21 and stuff, it all kind of mostly works out. So what that actually let us do was have, and it's also scope-based, so we can have really targeted scopes of things like clients referrals 1. So it's referral number 1 for that client, not the number 1 referral in the whole system, but just the first referral for that client. So the way that works, if I install another NuGet package, so this is also something we publish as open source. There we go. Is we have a unique ID generator. Some IntelliSense would be awesome. No, we're not going to get that. Oh, there we go. Now, and then the unique ID generator uses a optimistic store of some form. So it's got a file one, which is only really if you've got one machine, so it's great for dev, and that's about it. Or there's another store we've got where you can use Azure blob storage, which is the synchronization mechanism. Oops. And then off the generator, what I can do is say, just give me the next ID in a particular scope. So give me the next ID for a client, and that there is going to go and return a long. To then go and kind of, so imagine we then had client 1 and we wanted to generate a referral for them. What we could do is we can just say client 1 referrals, and we just make that the scope name, and then it starts at 1 and counts up again from there. So that worked really nicely for us in kind of, so the reason I'm talking about this in a graph talk is that it gave us the opportunity to do things like having that /clients/referrals/1, which makes a lot of sense in that highly connected space of we can have lots of nodes with all unique ID 1 persisted on them because we find them through a query of where they sit in the graph. We only need to identify them uniquely in that scope. Whereas doing that in the SQL world, you'd be talking like composite keys and stuff like that, which as soon as you say that, most SQL people kind of cringe. And then just to wrap that up, what we'd do is we'd have a public static class ID scopes. And we'd have something like referrals would take a long client ID, and it would do the formatting. So then what we'd do in here is we'd just go ID scopes dot referrals, and we'd pass in the client ID. So we got that nice and consistently. All right, so let's say now we want to go out and actually give all of our users in our system that we've already got unique IDs. We need to go and do some form of migrations and kind of evolve the schema over time. So what I'll do is I'll open up C code. We wait for the preview release of the operating system to wake up. Let's do it in here. Okay, my Alt tab's not showing anything and I can't click the icon. This is awesome. All right. Windows 2. And this is where we go change machines. People ask me why I carry 2 laptops. So the migrations, we always wanted to kind of evolve our schema, very similar to how you would just evolve a SQL schema over time. Get this projecting. There we go. So what we did in our application, this is a smaller app that I'm just starting to work on, was we have a migration service that just runs on startup. And what we did was we tried as much as possible to avoid what you generally do in kind of the SQL space is you go and check what version of the database are we up to, what changes have we applied, and then just roll forward new changes you need to do from there. Because we're in this kind of NoSQL world of this very soft schema, we also wanted to make it almost self-healing in a sense. So we make all of our data migrations where we can. We just look for something. If we find a particular pattern or we don't find a particular pattern, we go and create it. So here I go and check that particular supernodes exist, or we introduced a date created property after we'd already created a bunch of users. So just go and say, hey, show me all of the users that don't have a date created property, and then just go and set it on them. I mean, this code here can be improved a lot, but we don't have a lot of migrations yet, so it's all very procedural. And you can see there's a gremlin query there of doing the out relationships. And as we move towards mutable cipher, we'll actually be able to do those kinds of transactions in bulk updates as well, of just sending a single query to the server, rather than at the moment where we're having to sort of for each through things. And then specific to our neo4j client, because you can't always have a predicate for something, say a property not existing and therefore being null, but we don't want to expose it as a nullable property on the POCO, Like if we introduce unique ID, we don't want that to be a nullable long. In the where clauses, we also let you go and build up filters and things like that directly to support those migrations. So for things that aren't even valid in the way that you represent your .NET code, but being able to go and find those patterns and upgrade them as well. Now, in some cases, that doesn't always work. So where we went and had to clean up bad data that was very hard for us to detect otherwise. So something else that we did in that kind of idea of treating the root node as the system. Let's see if I can bring this up. C code. Was we did actually kind of track DB versions in the DB as well. I love how Internet Explorer gets freaked out about blocked content in an SVG file. There we go. So off the root node, we go and say it has versions and a version history, and then go and write out kind of what version numbers we've applied to the database. This particular file here, which is using that graph viz layout, does an auto layout, which isn't always great, but it's generally pretty good. One of the other things we then had, which was quite nice about a graph database over a relational database, was one of our requirements is we had to be a fully multi-tenant system, where we could actually, we're a hosted software as a service platform for these care providers, and they needed to be able to just sign up and have their own silo of data. And you obviously don't want details about children in complex family scenarios leaking at all. And we needed to be really, really sure that we weren't going to leak data from one agency into another at all. Now, in a traditional kind of relational database sense, we basically would have put like an agency ID column on every single table. We would have had to make sure that all of our queries went and queried by that. Or we would have had to go and actually shard the databases and maintain multiple databases or something, which makes the setup story a bit harder creating them. One of the nice things about using the graph database is off the root node, we then go and have individual nodes for each agency, and then all of their data exists off the graph. We then have some shared nodes for things like reference data, so we have a list of countries. So where we go and have like, we'll have reference data, and then we'll have 180 nodes for different countries, and then we'll relate things into those countries in some ways. But then what we can do is very easily, first of all, our queries, unless they accidentally walk via reference data, which we have things to protect that, our queries, once they start from the root node and go out, it's very hard for them to get into another agency, even though it's in the same database, because you kind of walked off into this part of the graph. You can't get back over there that easily. And to make sure that we didn't create any relationships between them, what we've actually got is just a single cipher query where we go and describe what we can do is we can say something like, okay, start at the root node is node 0, and then match from root any particular type of relationship any number of times. So actually we'd go from has agency to an agency, and then through any particular relationship any number of times to another agency. And then there's a way you can actually then go and wrap that in a shortest path function. And Neo4j will find the shortest path between those two agencies that doesn't go via the root node. And if that turns up as a non-null value, we go, oh, hold on, there's a relationship between these two agencies. And then basically the warning sirens go off on the roof and we go and diagnose what the problem is. So we then actually run that as part of our test cases through all the different environments as we go and restore data into them, which is a really cool thing to be able to go and query at a data structure level rather than trying to prove that our application code was safe and always queried the agency ID column or something like that. So that's multi-tenant safety. And the last part to talk about would be indexing. So I've talked a lot about going and sort of walking around the graph. In some cases, though, you do actually want to go and perform aggregate operations of things like, okay, we've got every single client and there's 100,000 clients, find me the one who's named Bob or something like that. And Neo4j does actually have an indexing platform built into it, and one of the ones that's plugged in by default is Lucene. So when you go and create a node, first of all, you can have auto indexing, but what you can do is you can say, okay, here's the node I want to create, and then I want to have these key value pairs in the index as well, in these indexes. So then for our tenant safety, we actually maintain independent indexes for each tenant that we have in the system. So we'll have like agency 6-clients as an index. It is a little bit manual at the moment. You have to say, okay, here's my node, and then here's the keys and values I want you to put in the index. But we actually found that quite advantageous because in our kind of node model here, we've got a concept of also known as, like James is also known as Jimmy and Jimmy the Kid and whatever. And that would be like one node for James, and then all these also known as nodes for all the other ones, because that's how we store the multiple values. But what we could then do in the index is, whilst we'd create a node called James, when we put it in the index, we could say name is James and name is Jimmy and name is Jimmy the Kid. And they all point to node, I don't know, 1, right? So then any match on that, searching in that index, matches back to the client, even though the reason that we match them is because they have an also known as stored in another node. So you've got that kind of level of indirection in the indexes as well, which we found really powerful for representing our domain model. So that's what I've got for today. The kind of what I wanted to walk through there was just about showing you that Neo4j is practical in a .NET world. I hate the fact that it has J on the end of the name, and I continue to tell them this because it scared us off to start with, going, oh, it's a Java thing, that's going to suck to integrate with. But it's actually getting to be a really, really nice platform to use from .NET. And it's the same way that you don't care what SQL server is written in. It's just an implementation detail. So it works for us. We've released a lot of open source in terms of SnowMaker and also the Neo4j client, and that's starting to get a good amount of traction, which shows me there's a lot of developers picking things up. We get a pull request for Neo4j client about once a week at the moment, and we publish about kind of, I don't know, 10 builds a week. So there's a lot of activity in that space, not just from us, which is awesome. So there's the 2 links to it. Any questions? Yes? Yep, the query to protect the agencies. How long does that take to run? At the moment, we've got sort of 3 agencies with a couple 100,000 nodes in each of them, and we run that query in, I haven't instrumented it, but it's somewhere like a minute or something, or maybe 30 seconds, because we use a shortest path algorithm, and there's a whole bunch of different graph-related algorithms like that in Neo4j. Normally, you wouldn't walk every single node in your database like that, but it's very good at going and chopping out bits that aren't relevant and realizing there's subgraphs and multi-threading that and all that sort of stuff. But there's lots of different algorithms in there for doing that. It's really efficient for things like, say you want to do transport routing, for example, and you go and have lots of different bus stops, and then each of them is nodes, and then you have relationships between them which describe the bus routes. And then on the relationships, you can actually put data in there about how long that bus trip takes. And then you can go to Neo4j and say, hey, find me the shortest path between this node and that node where it's weighted on this property. And it just has all that magic in the box. So I don't even know how those algorithms run so quickly. They just do. Which is good. I don't really want to go and study path traversal algorithms too much. It's a little bit scary. Any other questions? Yep. Sure. So the question is about, is there any security in Neo4j? At the moment, no, there's nothing. It's all at the network level. Basically, if you can connect to it, you've got everything. And then the idea is that you do all your security in your application. It's very hard to apply a lot of those sorts of concepts to a graph model because as far as Neo4j is concerned, it can't tell like so in that first example, it can't tell what's a person node and what's an activity node and those types of things. So you can't really do those same concepts that you could in SQL of saying grant read access to that table or that category of data. It's just got no way of knowing what it is. So in that sense, because it's so much more complex, there's not really been a lot of push for them to try and implement something around that. One of the issues they are having at the moment, though, so there's Neo4j is available as an add-on on Heroku. You can just say add it to your application. The Gremlin query structure is built on top of Groovy, which is a scripting kind of dynamic layer on top of Java. So you can actually go and just run arbitrary script in Groovy. So they're having to go and segment all that off at the moment. and they're trying to deprecate Groovy because of the security risks around it and move to that more declarative cipher model as well. It got a little bit scary when we were building our client initially supporting Gremlin because we're translating the predicate. So we're taking a C# lambda expression and having to translate it into a Gremlin predicate. Because Gremlin is GroovyScript, which is Java, I actually ended up writing a method once called encode string as Java string. I was like, am I doing something wrong here? But so we've hidden all that away and we've buried it, and Cypher's a lot nicer now as well. It's a much more descriptive language. Okay, thank you. I'll be hanging around for any questions.